Hello, everyone. Welcome to the edition of Data Science and Artificial Intelligence in Africa. Today, we have Mabu Manaileng from South Africa, who is the lead data scientist at Undergrad Group based in Joburg. So now we're going to go over to Mabu so he can introduce himself and tell us a bit about his background and how he got into data science. Welcome, Mabu.
Yeah, sure. Thank you. Thank you so much for having me. And yeah, I'm really glad to be here. I like your work, what you're doing in terms of, trying to communicate the data science efforts in Africa, which is really great. And for me, from a background perspective, so basically my data science journey was quite interesting. And I think I've been sort of privileged in terms of having been able to study the stuff that will help me, with my data science journey, without having known actually intentionally whether it was not a plan that I'm going to study this so I can be a data scientist or a machine learning engineer, really. But then it just turns out that whatever I studied fits very well in the field, and then I had to just make a few adjustments. So I started out with an undergraduate computer science degree. Yeah, I did a computer science degree. And I remember we had applied mathematics, computer science, statistics, and mathematics in our undergraduate. And then when I went to my second year, it's actually compulsory, so you can't graduate computer science without having finished second year mathematics at least. So I dropped applied mathematics when I went to my second year studies and did statistics, mathematics, and computer science. And then when I did my final year, I had this ambition of doing a triple major where maybe I can graduate computer science, mathematics, and statistics. But as it turned out, mathematics and computer science 3 were too heavy to be doing in 1 year. So I think at some point I went back to deregister mathematics so I can only graduate with computer science and statistics. It was also not a very planned move to be I wasn't really trying to achieve anything. It was just that mathematics was too hard to do with computer science at the same time. Don't have too much time to write the code and figure out all those theorems that you need to figure out in Math 3. So it wasn't really a plan, but I just so happened to actually keep statistics and computer science, which would later help me a lot because then when you have statistics and you have computer science, those are very nice combinations for machine learning and data science. So then I got introduced to sort of artificial intelligence in my third year computer science program. We were doing this heuristic learning stuff, and I got super fascinated by the whole concept of building machines that can, do statistical approximations or do some kind of learning that can be unsupervised or just data centric. So those concepts are quite interesting to me. Then, unfortunately, it was a semester course, so it was just one semester we did, introduction to heuristic learning and artificial intelligence and stuff like that. So I got interested, and then when I spoke to the lecturer who was giving us the course, he thought that maybe an honors degree will be useful so that I can get more into what was heuristic learning, what was artificial intelligence in general. So then I registered an honors degree to focus specifically on computer science, looking at artificial intelligence. And then we had a research center there on campus where people were focused on things like spoken language processing, and we got some funding from industry partners. So then it was quite natural for me to just after I do my honors degree, to just go into a master's program so that I can also go a lot more deeper into the subject. Basically, I felt a bit even after doing the honors, I felt oh, okay, I get it. I have a sense of how to build and train a model, but I still really didn't get the gist of all of it. So then I did a master's degree where I was focused entirely on natural language processing, particularly for under-resourced languages. So I was working on finding what we call acoustic modeling units when you are dealing with digital signal processing. So when you are dealing with things like spoken language, it's a bit different from when you are dealing with a written language. So NLP in general, the field has very different approaches from used to. These days, I can see that with the whole advent of neural nets and large language modeling and stuff, the spoken language versus written language is becoming a bit of a blur. You can do multimodal models that really don't care very much about the distinction. But yeah, so we were focused primarily on spoken language, and the idea was to build the systems we call synthesizers and recognizers. So when you speak into a microphone, I can do like automatic speech recognition, and then if you want the computer to do the speaking, then you do like speech synthesis, where like you have vocoders and decoders that sort of try to take the acoustic signal and synthesize it in a way that should sound like a bit more human and all of those kind of things. So my research was focused primarily on trying to figure out what will be the most ideal acoustic units we can use to build these models without having to rely on too much data, because under-resourced languages by definition don't have too much data. So it's like you need to find a way to build still competitive systems without necessarily relying on techniques that require you to have a lot of data. So other people who are using phonetic-based approaches, where they'll use like the actual phonemes, which is the individual unit of recognizing sound. It's like the so we use phonemes to as a language is broken down into phonemes when you are listening to it. And then the idea was we don't have that phoneme to sound to syntax mapping in most African languages. So it's very difficult to use that technique to train the systems. So then we took a grapheme-based approach, which was saying that instead of trying to model them with the whole phonetic approach, we take a grapheme-based approach where we rely solemnly on the syntax of the language rather than how it sounds or blah, blah, blah. But then we model, we build so basically the syntax to audio mapping with the actual syntax itself without having to manipulate it. So it's like if a word is written as love, and then we just model it as love, but we don't sort of try and break it up into phonemes to say LO is put together, VE is put together. But what we do is that we just say the whole word as it is. We're going to try and find the most accurate approximation of its pronunciation. And also we can do the same thing when we do recognition. So it was quite a heavily involved project that focused a lot on like super low resource languages in South Africa. We picked some languages to experiment with, and then we built systems that could get rid of the phonetic association, and then just do like grapheme-based recognition and compare them. And then my research obviously showed that you don't always need to rely on phonetic approaches. You can take grapheme-based approaches and still build sufficiently performant systems that are in under-resourced settings. So it was quite interesting. And then so after my master's, I just went into industry. Actually, my dream was to just be in academia forever. So I sort of fell in love with
Really?
it. Yeah.
That's like the opposite. With me, I never wanted to further my education. I was like, after undergrad, I'm done.
I did not want to leave campus. I mean, so I went on campus, and then I undergrad, honors, masters straight. I never took a break. I had intentions of doing a PhD also, and then just come out of academia with a PhD. Also, I did not have intentions to come out of academia. So, I was already like writing papers, traveling Europe and all of this, and it was quite a nice pack to be in academia because you can do that. And I also like the idea of research, to be honest. I was a research assistant at some point, and then I was also responsible for building pipelines, writing code in Python, in Bash, so that we can build a small scale recognition, modeling experiments and that kind of thing. So I was really in love with the idea of staying in academia and then doing that as my job. But then as part of my funding, the organization that funded me needed me to work for them after the master's program. So then that's how I left academia. And then, when I got to industry, I found that, there was not a lot of machine learning that was happening, and data science is this is like when 2015. So in South Africa in 2015, data science was still mostly a buzzword, and people were like really trying to put together Hadoop clusters and just the infrastructure so that people can actually start running experiments and doing the data science. So they struggled a lot with that, and I sort of tried finding anything that I can do with data so that I'm still even when I'm working, I'm still like a practitioner, but it was quite hard. And then I remember, out of frustration also, a colleague of mine who had left me on campus and then went to work for a company called CSIR here, the Council for Scientific and Industrial Research. It's quite a sort of an academia type of institution, but that tries to bring industry together. So it's quite nice. So I was working there doing some machine learning stuff, and then we got together and said, let's start a company that's going to focus on doing machine learning, because we can't do machine learning sufficiently in our roles in the corporates that we work for. And also, the thing that also irritated me was that there was a lot of thinking that machine learning doesn't really work. It's like overrated, and data scientists are just like expensive things that are not necessary type of thing. So there was a lot of that kind of stigma. And when we founded the company, what we wanted to do is to like get into these organizations that think you can do it and sort of do some consulting work and show them that you can actually build models. Even at the time, building like sentiment classifiers and other things was still heavily involved. So it wasn't as easy as today, where, you have like zero-shot classification techniques, and it's very easy to build a sentiment classifier today. You actually don't even have to build it, because you can just get a model that does a zero-shot classification, and then you take it from there with transfer learning. So it was still quite hard at the time. So we would do things like that. We would come in and then scrape your Twitter data and then show the company that, look, this is the sentiment, and then this is what's going on, and then location-based stuff. And so people started seeing value out of it, to say, oh, actually, this is quite useful. And even large-scale analytics projects where, people wanting to know simple things like, which of my customers are buying more of my products? What can I do? There were simple data questions that people couldn't answer, because there was difficulty in sort of even putting the tools together and just to try and make something meaningful out of it. So Data Wizards was born out of that. And we also started doing like hackathon stuff too. One of the things I cared a lot about was to sort of let other developers, let other software engineers understand how machine learning works, so that they can start trying to incorporate it into their own development. So when we went to hackathons, we've got a bunch of local hackathons here. There's an organization called Gig Culture, which is really doing amazing work in terms of putting developers together so that we can exchange ideas and compete in hackathons and stuff like that. So we went to lots of hackathons and competed with like machine learning data stuff, won a couple of them. And also by doing that, most of the developers then were in like becoming interested to say, oh, but you built a model, you did a demo of this app that's that's making an API call to a classifier. And then people started like sort of getting really, really excited about data and machine learning. And even today, I think our hackathons are almost gravitating towards data analytics and machine learning based sort of problems, instead of just like build an app. But it's like build an app, but what kind of machine learning model are you using and stuff like that. So that's sort of been my journey. And then I left. This is a private company that I co-founded with my colleague, and we're still doing that kind of work and really just like allowing companies to productize machine learning, if you like. And it's like, how do you really make it work? And then go beyond the theories that most executives actually still struggle to sort of think that machine learning is valuable. It's like, do I have to pay this expensive skill set, or we can just do it in Excel? And it's like when you are in the role, you have a very huge responsibility of also making sure that you remove the stigma, and then you actually educate people about how machine learning can work and how they can find value, because it's still quite problematic in most instances. But yeah, so now I work for Standard Bank, obviously, and I served as a sort of a senior manager of data science for a while, where I was doing sort of basically as a technical lead. So my role would be, to identify what models we have to build, what are the tool sets, how do we deploy, how do we do all of those things. And then I'll have a bunch of people that I work with that I, sort of orchestrate and put together, so that a data engineer is working on data engineering problems. And then I'll also sort of do a lot of like solution architecting. So it's like, once we get the business problem, what will the components look like? How do they fit together? What kind of architecture can we use from a modeling perspective? Is this like, a computer vision issue that we can use, or is it multimodal? Is it a language modeling problem? So all of those kind of things, I have to figure them out and come up with like product roadmaps to say, what is going to be maturity of our integration of machine learning into what we're working on, and that kind of thing. But very recently, my role changed actually. So now I'm a principal AI engineer. And then my job now, it's sort of similar, but it's also about really demonstrating the value of applied artificial intelligence. And the idea is also that we go beyond, Jupyter notebooks and then my models running there, and then actually start integrating. And then, our products need to be AI first. We need to build machine learning enabled tools for even internal stuff. For example, we can think about a call center operation where you build like machine learning tools that really supercharge your agents. And then you get also like identify like revenue streams, potential monetization aspects, and things like where can we cut costs using automated machine learning tools, and stuff like that. So quite an exciting role. And it's still really about demonstrating that artificial intelligence, if harnessed and used properly, can obviously do wonders. I mean, we understand why companies like Facebook and Google invest billions of dollars in AI, because they know the value of it. And then we just need to figure out how we can also harness that value and do similar stuff. So that's sort of been my journey in general. I do have other interests and stuff that I like working on outside Data Wizards and outside Standard Bank. But yeah, at heart, I think the academia in me is still there. So love reading papers, love trying new things, and yeah, so that's basically me in a nutshell.
Okay, you've had a quite interesting journey, I think, from starting from your computer science, and like it wasn't intentional for you to get these skills, and then over time to going to your master's and working on these different projects, and now to your work, starting a company. So are you still mainly interested in natural language processing, or you are now venturing into other things? Like, what's your main interest right now?
Yeah, so naturally speaking, because I specialized with NLP when I was in my master's, I'm much more inclined to solve problems I solve NLP problems quicker than other problems, but I'm not a specialist. So I don't regard myself as like an NLP specialist or anything like that, because I prefer, like when I left academia, so I'm no longer a researcher per se, but the research is still in me, but I prefer taking an applied approach to machine learning. So the idea is to use the tool to solve a specific problem. So because of that, if I come across a computer vision problem, I can take a pre-trained ResNet model and then, fine tune it on some upstream task and do some classification thing, or I don't know, semantic segmentation. So it's still fine. And I think that this is the attitude that I would encourage everybody to do. That you need to be competent across the stack. It's not that you should, be like, nah, I do computer vision stuff and then I don't know anything about NLP. I think that's not very useful. So what we should be doing is, especially from an applied perspective, I understand the researcher who is producing the knowledge that they may not be able to, be specialists across computer vision and all of these other fields. But for us as people who are not necessarily sitting somewhere in Google research and writing the papers, but we're people who are taking business problems, applying them to these technologies to find useful solutions, we should be able to be competent across the stack and even be familiar with like multimodal models. Models like DALL-E, where you combine natural language and computer vision. And obviously, we should be able to be competent when you come across a forecasting problem, be able to, understand how you can use Prophet or some other tool set out there once you understand the science of your data and then what you need to be forecasting. So I really don't think that we should specialize and say that I'm only good at this and then the other ones I'm ignoring. Although it does help to sort of have some serious depth in one of it, in one of the fields. Like if you really have like some serious depth in computer vision, where you understand like self-supervised models that are coming out of the industry for doing like semantic segmentation or that kind of thing, and then you sort of like really have so much depth with that. It can be useful because you can also monetize your depth, as in like some people who sort of generalists who know a little about everything, then when they come across like a serious problem, they lack enough depth for them to know how to unpack that problem because they only know the little of that field. So there is merit in terms of trying to be specific and specialized, but that's why I think it's important to just continue reading research papers, continue when a tool comes out, play around with it. When Facebook releases a model called Dino or something, take the model and then read the paper, look at the code, and then so that you don't get left behind across the whole machine learning stack.
Yes, I think what you're saying is right. In as much as I think you should try to get some depth in like one or two like special, like what are they called? One or two fields in that. I also think that you should just try to play around with everything that's out there. Not necessarily everything, but in as much as you can. And I also think that it's a problem that we face with hiring managers, because they will tell you that we want someone who is skilled in this and this, but they will not allow you to say, no, I've worked on a separate problem, but the concepts are related, so I can try to work on this new thing. So I think what you're saying is right, and it should be not just for us as the technical people, but also for people who are hiring, to say that we don't need someone who is a specialist in one particular field, but someone who can play around with other things.
Just on the hiring managers, actually, because I think that is an important point, right? I mean, if you look at job descriptions as well, you wonder, what kind of person are you looking for? Because this job description, the things you're describing that this person has to do, it's like, a bunch of PhD people in one person. And it's, I think it's quite problematic from a hiring manager's perspective to not really sort of understand the meat of what a role involves and be able to be specific about what you're going to be doing. I mean, even from asking what kind of tool sets, they'll go from Kafka to Kubeflow to AKS to, like, even when they say which cloud are you competent in, they don't say, preferably Azure or anything. They say AWS and Azure and GCP, it's like, it's a mesh of all the kind of skills that, you'll find in different people. And then they want them in one person. But I think it also touches on this full stack conversation. There is a if you're just a regular developer, it's not a machine learning, it's not data science, you just build apps or systems and stuff. Usually when they say full stack, they will mean that, you understand the server side, you understand the client side, you understand the databases, you understand APIs, and then you can be a full stack in that way. So for machine learning, when you say full stack machine learning engineer, it's quite scary. I mean, what do you mean?
What do you mean? Because there's so many things.
But I think it's quite interesting.
Okay, so I wanted to understand, because is it from your experience, or maybe now that you're working with your juniors in the organization that you're working for? Because I saw that on LinkedIn, you were talking about how recent graduates don't really know much about what they're doing. So they come like ill-equipped with maybe skills or critical thinking, something like that. So can you explain more on that? Like, what would you like advise people who are like graduating and going into industry to work on?
I think it's actually quite an important topic, and it's one of the things that I think ends up creating this stereotypes in data science, where it's like everybody just label themselves data scientists. There is that perception that these days everybody just calls themselves a machine learning engineer.
Yes.
Because you can pip install Anaconda or something, and it's like, okay.
Yes, and you can plot something.
Yeah, and I think in general that creates it's not good for the industry, because then even with the online certification, people do lots of certificates online, and then it's like somebody has like 100 certificates from NLP, computer vision, to all sorts of things, and then when you test the content, it's like all certificates but zero application. It's like there's and the data science is a very applied field. It's not, it is theoretical, but it's like the theory doesn't make sense if you're not playing around with the theory. So one of the concerns I have is that we do that. We just go online, get a lot of certificates, watch videos, and then say we are data scientists. And then when I give you a problem, you really struggle to just understand what a mini batch is, you know, or if I say write a loop and then manipulate the batch, all the batches that you get for every epoch, then the code can't come together. And it's like, but you have all the certificates. What were you doing? And so what I think also is that universities also don't prepare students to work with these tools. So what they do a lot is that it seems to me that there is too much theory that goes in, and then you find this very nice academic transcripts with like distinctions in computer science, distinctions in this, distinction in that. But then when you're in the actual interview, you can't really solve the problem. And your distinctions are not, reflecting your technical aptitude and from an execution perspective. So I'm really worried about that. I think that people should really balance the distinctions that they get and also the number of hours of videos that they watch online in terms of trying to get into the massive open online courses movement. They should balance that with like writing code. So it's not uncommon to find a person studying a PhD, I don't know, in computer science or something. And then when you try to just get them to write a simple algorithm, they struggle, like they struggle with concepts like for loops. It's like, it's really a concern that we read too much, watch too many videos, and do very little of practicing, very little of writing code, very little of trying things out. Like if you say to someone, have you been able to set up an automated CI/CD pipeline? And it's like, if you're asking a data scientist that, it's as if you're unfair, because it's like, no, I'm supposed to be knowing about gradient descent. What do I care about CI/CD? But in practice, all of these things come together. In practice, I always make this argument that there are instances where I would want to work with somebody who knows how to use TensorFlow and then be able to train a model with TensorFlow, deploy a model with TensorFlow, and then, expose it as an API somewhere, maybe deploying inside a fast API app or something like that. I'm comfortable to work with somebody like that who may be able to have those skills, but then not necessarily understand, the difference between, let's say, stochastic gradient descent and something else, right? It's like, if you don't understand the nitty-gritties of what TensorFlow is doing, but you're able to use TensorFlow in production settings and be able to train and analyze a model and do that, you don't necessarily know how TensorFlow is doing it in the background, but you know how to use TensorFlow for your specific problem. That is much more useful sometimes compared to somebody who sort of like really has the theory of it. He understands the theory. She understands all these things that are going underneath, but then they are unable to just take data from one place, use that tool to do something, and then deploy to production. So there is a balance, because you also don't want to just use the tools without necessarily understanding what the tools are doing in the background, because sometimes you have to debug. But it's like, while you are understanding the tools and having an appreciation of what they're doing in the background, that is very useful. It's unlike if you sort of just has this very rich knowledge of the theory, but you can't practicalize it. You can't solve a problem that I'm giving you, regardless of how much theory or definitions of things you have in your head. So I think that is my concern. And universities in general do not bring out, people get out of university with degrees and then they still don't know what does exposing a model as an API look like, It's like they understand the training, they understand the gathering of the data and the analysis, but they have not been able to just expose it as an API and make a RESTful call to that model to get predictions. And it's like, some people say universities are not supposed to be teaching people that, and I'm okay with it if they're not supposed to, but people should at least then take the effort of learning to do that. If you can combine what you're doing in class with what's going on the internet, and then how to deploy, how to do this, how to operationalize machine learning, then you become a better person. And I think that's the niche we want. We want somebody who has the strong theory, of course, but also is able to practicalize the theory.
Okay, I do agree with what you're saying. but then also knowing how university is like, and how, sometimes you just work on your assignments, you're good at what you're supposed to be good at, and then maybe you go one or two steps further. But not a lot of people will go further into like learning how to deploy, how to create an API. But don't you try to like find maybe someone who you think that they look like they're motivated enough to be able to learn that and then use that in practice when they are working, like sort of like allowing people not to know everything. Like, for example, when you're interviewing people, is like, don't you think people are allowed to not know everything, and then they can learn some of these things when they are working now on the job?
Yeah, I mean, all of us don't know everything. So I think there must always be room for allowing people to grow into a role, especially from a hiring perspective. But I think there are red flags. So I think if I'm in an interview with you, personally, what I try to do is establish where are you on the spectrum, right? Like I said, that you can think about a distribution of, on your left tail, you have like very theoretical people. And then on the right tail, you have like very, very applied people who can write apps, and they know C#, they know CSS, they know JavaScript, they know all these things. And then if you tell them that there is an API that is a model, they'll figure out the schema in which they should call the model. They'll figure out or maybe they're even using a high-level tool, maybe let's say PyTorch or something. And then they take a pre-trained model from somewhere, and then they say, okay, cool. Can I use this pre-trained model in my Python code to make predictions? You find somebody who has that knowledge, but it's on the other extreme side of like, I can use models, I can do this. But then when you go deep into the theory, they don't have it. The other one on the other extreme have all the theory, but they don't even know just how to say from PyTorch, how can I take a pre-trained ResNet model and then use it in my Python code? But they know exactly everything about padding and strides and convolutions, but they don't. So it's like what I look for is where are you on the spectrum? Because then we can say, oh, you are on the far right. Then we can help you understand, how padding works and what is the importance of a stride and a filter in a convolutional neural network. Or then we can say, oh, you know everything about this, but you don't actually understand how you should just very quickly take PyTorch and then use a model that's pre-trained or something like that. So we at least have to understand where on the spectrum are you. The red flag is when I'm unsatisfied with the theoretical questions that I'm asking, and I'm also unsatisfied with the applied questions that I'm asking. And then you are somewhere in the middle. And it's not a useful place to be, because then you don't know either of them. So I think, yeah, pick your struggle, and then every job has its own demand. There's no job really that wants you to be like a full stack. I mean, some of them do. I consider myself a full stack. So I can go from collecting the business requirements to I deployed an app in production and users can use it, like where they log in and start using it with the model in the background. So because, I know HTML, I know but it's not like we're not looking for that in everybody, but at least pick your struggle and understand exactly what is your competency, what are you good at, focus on what you're good at, and then be good at it. The rest of these things, yes, you can learn on the job and blah, blah, blah. But there's really certain things I do not expect to teach you on the job when I'm hiring you. It's like there's certain things that I'm assuming they are prerequisites. You need to know this, then the rest of them we can work on them. So at least if I find you somewhere on the spectrum, then I know what I'm working with. But if you sort of just average in the middle of everything, it's a bit problematic.
Okay. Yeah, I definitely understand what you're saying. So now that we are running out of time, I'm just going to ask like two important questions for me. Okay, the other one was advice for people who want to do what you're doing. So from what we've talked about, you've pretty much given advice for like people who are in undergrad or maybe doing their graduate school, focusing on data science or machine learning. But what would you say to a high school student who wants to get into the same position as you are?
Yeah, you have to get started. I think, so coincidentally, I have a mentee who's in high school.
Okay.
Yeah, doing brilliant things. I work with him a couple of times on projects, and already knows how to train an LSTM, already knows how to quantize a model and deploy it on an Android app and stuff like that. So data science is a democratizing technology. Machine learning is a democratizing technology. All you really need is internet. If you have access to the internet, you can teach yourself anything. I mean, I believe that universities are not necessarily essential for becoming a data scientist or machine learning engineer or whatever, because you could learn what they could teach you at university somewhere on the internet. I mean, I think it was Elon Musk who said the internet is the greatest college in the world, which is true. And I think people don't take advantage of that. So if you're in high school or blah, 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 get started. One of the things that I always wished, so I touched the computer for the first time when I went on campus. So it was like for the first time I actually touch and use a computer was when I got to campus. So it's like, had I known about it and played around with it, a couple of years before, some advantages, right? So,
but when was that?
So that was in 2009. So February 2009, it was the first time I started using a computer, like understood how the mouse is moving this thing. I remember in our computer lab, I had to ask one of our lab assistants that, can you just help me connect it? Like, let's sort of take it apart. So you tell me this one is connecting here because of this. This one is connecting here because of this. Even the network cable, I didn't get that. It doesn't work. You can't go to the internet if that network cable is not plugged. So many things that I didn't know, and I wished that I knew before I got to campus. So I feel like if you're still in high school or what, the greatest opportunity. Start coding, start writing code, play around with building a simple website, build an app, then get into the data science stuff, right? Because I think sometimes it's also problematic if you are data science inclined, but you're not very code proficient. Like you don't understand like coding concepts, like what is the difference between a class and a function? Why would you use one over another? When do you need to do this? Like, so if you teach yourself how to code, that broader perspective is going to help you come into the data science thing very nicely. And absolutely, there's no limitation. You absolutely don't need to have a college degree just to understand how to build an app, how to build a website, how to integrate it with the machine learning model, how to go get data somewhere and then do this. You will, if you start early, you will make your knowledge very concrete over time by knowing which content to focus on and then identifying your gaps and then filling them up.
But it's also something that I'm always telling people who are always asking, how do I get started? How do I get into this? Especially people who have graduated. For me, I'm always telling them, you know what? The best thing that you can do is just try to build a portfolio of like small projects that you've worked on, just to improve your skills and also show the people out there, like the people who are hiring, that you can actually do this and this, so that people know what you're capable of. And then moving on to the last question, because people don't really get so if you're saying you're a data scientist, when you get to work, what is it that you do? Like when you're sitting in your office from 8 a.m. to 5 p.m., what does it look like? So what does a day at work look like for you?
So I think it would be easier if we start with a new problem. So suppose that, there is a new incoming project that is incoming. So basically what that would look like is typically you're sitting with people trying to clarify what the problem is, right? So for example, I'm currently working on, for example, a revenue forecasting project. And what that means is that, so businesses identify that we need to forecast revenue of specific merchants, for example. And then it's like, there is reasons that you need to go into, but it's not always up to you, right? Whether a project comes in or it doesn't come in. So it's like, there is other things that you can understand, the context, the business value of things, the blah, blah, blah. But yeah, that's a separate topic altogether. So suppose now that here it comes, and then where's the data, right? They say, you're going to forecast this, where's the data? Then the day typically would be getting that data. So let's say you're analyzing it. For example, you're just checking, it's a forecasting problem. So maybe you want to test things like stationarity of what you're trying to forecast, if there is seasonality in there or blah, blah, blah. So that is analysis. So that's like, typically we'll be writing a lot of Python code. It could be like on a Jupyter notebook, but I typically like productizing my machine learning work. So even when I demonstrate, to executives or other people to say, this is what the data looks like, or this is what the model is doing, I want that to be inside of an app somehow, a kind of a website, so that people don't see code, people don't look at, so it will be me building something like that. Usually I can use tools like Streamlit or Gradio. And then I do that. And then, I have my model. I trained my model. Sometimes training the model means you need to log into some GPU compute in the cloud, where maybe you're building a deep neural network that needs, like, it's data hungry and then compute hungry. You can't train it on your computer. Typically, to be honest, in production settings, your computer is not sufficient for doing the training of a model that you want to deploy. So I'll be in the cloud, jumping around between the cloud, my local computer, writing a lot of Python code, visualizing, looking at graphs to get a sense of what I'm working with. Sometimes if the model is still training, I'm waiting for it. I can be working on another project on the side. And like I said, my intention is to be a full stack. So I always want to make sure that I understand JavaScript, I understand how to use jQuery, I understand all of these kind of things that will help me in the long run from an end-to-end stack perspective. So then that also involves a lot of presentations. So you, as a data scientist, machine learning person, you also need to work on your communication skills, because then you are often required to present stuff to people, to let them know, and which is where also knowing the theory behind things becomes important, because you could be presenting a forecasting model and then somebody asks you a very super technical question, whether you are using a sliding windows, are you windowing your data for your forecast, is it autoregressive? And then you have to sort of, you have to own your craft, because then you have to understand, also deconstruct the technical conversation into a businessy language. That is something that also it's useful to be fluent about. So that will be typically it. Getting data from somewhere, analyzing the heck out of it, trying to know what model to build, building that model, trying to figure out how am I going to present the model, how are we going to measure the model, how are we going to define the metrics. And then in business context, usually you'll have to go through a series of steps, including like sign-offs, where people say, we're signing off the model. There is like quantifying the risk of the model, the error rates. There is a lot of things that needs to be done, but all of it, basically, it's writing a bunch of Python code, connecting to a bunch of data sources, deciding what model to build and stuff like that, and also finding a way to present it in a business sensible way.
Okay. This has been very informative for me, because I've never spoken to someone who is in the industry in South Africa. So I just wanted to understand. I'm obviously going to be speaking to other people, so I'm just going to eventually understand what is the industry space like with data science in other different countries as well. But thank you for making time for this, because I feel like people from data science come from different backgrounds, and we have different educational experiences and reasons why and how we got into data science. So I feel like over time, as I continue to interview other people, it will be clear for people who feel like maybe they are in a field that is far out of reach to get into data science. For them, it can be clear what their journey could look like if they want to get to do the same thing. So thank you for making time for this.